falling into a black hole would be easy. You'd only have to let go. No gate, no sound, no warning. You only notice when it's already too late. And the strange part is, if you jump, there are two versions of your story. The one you live, and the one everyone else sees. We'll talk about your fate later. First, we have to settle the thing that decides everything. What is space? And what is time? When we say space, a lot of people picture emptiness. Space is not empty. It defines how far things are from each other. It tells you what straight even means, and it decides what motion feels like. Think of space as an invisible order, spread everywhere between things. Gravity isn't simply a force that pulls. It bends space, and with it, the paths things take. A planet bends it a little. A star bends it hard. And if you compress an enormous amount of mass into a tiny amount of space, the distortion becomes so extreme that nearby, everything falls inward, no matter which direction you try to go. A black hole isn't dark first. It's first space curved too violently. And when space bends that much, it doesn't just bend the path. It bends the one thing we treat as untouchable: time. What is it, this time? In daily life, we pretend there's a shared now, as if all clocks in the universe basically tick the same. They don't. Time depends on how fast you're moving and how strong gravity is near you. In stronger gravity, time runs slower than in a place with weaker gravity. That's measurable. Satellites have to account for it, or their signals don't line up. And when gravity becomes extreme, the effect becomes extreme. Meaning, near a black hole, where time itself curves, for you, it's just a breath. For the world out there, an eternity. Now we have the two ingredients. Space can distort so violently that outward eventually stops being a possible direction. And time can run so differently that two people don't just feel differently, they measure reality differently. Now we can explain what that invisible boundary really is. A black hole has no door, no wall, no sign. And still, there is a boundary. Not because matter sits there, but because beyond a certain closeness, even light can no longer escape. And since light is the fastest messenger, that means whatever happens beyond it can never tell us about itself again. No light comes back. Stars orbit something invisible. When black holes collide, we measure ripples in space-time, gravitational waves. We've even captured their shadow indirectly. The Event Horizon Telescope doesn't see the hole itself. It sees the signature of its boundary. That bright ring in those images is not the horizon. It forms just outside, where light can still loop around the black hole before some of it escapes. That's why it looks like the hole has a glowing edge, even though it stays dark. We can't look inside, but we can measure the consequences. That's why it's called the event horizon. From there on, nothing reaches us anymore. No light, no signal.
It's not an object, it's a line in space-time. Past it, there is no road back out. That's the theory. For you, it would feel normal until it's too late.
Then you let go. At first, you feel almost nothing. You fall, weightless. Only the light around you looks distorted because space itself is distorted. As you keep falling, your time splits from theirs. To someone far away, you look like you freeze at the edge, not because you slow down, but because time in strong gravity doesn't pass the same way. And if someone could pull you back right before the boundary, for you, a breath. For the outside world, a lifetime. And your family? After centuries, you wouldn't even be a name. And your world? It wouldn't just have moved on. It would have become another world. But you keep falling. Your light turns redder, fainter, because escaping that gravity becomes harder and harder. To the observer, it looks like you approach the horizon, but never quite reach it, like you slowly fade away. For you, it's different. You pass through, and nothing happens. You're simply on the other side. Now imagine something very simple. You're allowed to send exactly one sentence before you jump. Just one. Not to save yourself, only to prove, I was here. At first, that sentence still arrives. But the closer you get to the boundary, the longer it takes, and the weaker it becomes. Then there's a point where no further sentence from you will ever reach anyone again. Not later, never. That is the event horizon. Not a wall for you, but the limit for anything that could still prove you. And then, only one question remains. What happens to a person who is still there, but no longer reachable to the outside universe? A lot of people imagine instant destruction, but it depends on how large the black hole is. The decisive effect is tidal force. Your feet are closer to it than your head, and closer means stronger pull. If that difference is small, you notice little. If it's large, it becomes brutal. It doesn't pull evenly, it pulls unevenly. You're stretched and squeezed. The word for it is spaghettification. It sounds almost harmless. It isn't. Near small black holes, it happens early. Near supermassive ones, the horizon can be so large that you can cross it before your body tears apart. But even there, there's only one direction: further in. Past the event horizon, there is no direction that leads outward, not even with rockets. Not because you lack force, but because geometry no longer allows it. From here on, The center isn't just a place, it's something you will inevitably get closer to in your future. And the closer you get, the stronger the tidal differences become. At some point, it becomes too much. And then you reach the point where our models fail. At the center lies what we call the singularity. But that's only a name for our limit, because singularity mostly means, in our equations, the values become infinite. And infinite in physics is often a warning sign. The model breaks here. Maybe there's something extremely compact. Maybe quantum physics changes the picture completely. Maybe the center isn't a point, and point is just the word we use when our imagination runs out. We don't know. From the outside, we can describe black holes by mass, spin, sometimes charge. But what that means inside remains open. And this isn't just theory. We find black holes by what they do: glowing accretion disks, violent jets, and star orbits around invisible masses, so compact almost nothing else fits. Then came the Event Horizon Telescope. It made the shadow visible, a trace of the boundary where nothing escapes. But even that finality may not be final. And even that isn't the end. Black holes are not forever, at least according to what we understand today. There is an extremely faint radiation associated with them, Hawking radiation. Not because something burns inside, but because empty space isn't truly empty in quantum physics. Over unimaginably long times, the black hole loses mass. The smaller it gets, the stronger this effect becomes. At first, it's barely more than a whisper. At the end, it would be a short burst of high-energy radiation. And then, silence. Only that end lies absurdly far in the future. Up to this point, we've talked about things we can measure indirectly: orbits, radiation, shadow structure. Hawking radiation is different. It's so weak, we haven't observed it directly yet. A black hole with the mass of our Sun would take about 10 to the power of 67 years to evaporate. The largest ones, closer to 10 to the power of 100. Don't picture a calendar. Picture a faucet that releases one drop every 10 billion years. And you're not waiting for a glass to fill, you're waiting for an ocean. Even then, with the largest black holes, you still wouldn't be anywhere near the end. If a black hole disappears someday, where does what fell in go? And that brings us to the real question. If you throw something into a black hole, a book, a photo, a name, a memory, is it truly gone? Or does the information survive somehow? If a black hole disappears through Hawking radiation, you have to choose. Either information is lost, then there are places in the universe where truth ends, or information is preserved, but in a way we don't understand yet. Both possibilities break the mind. And that's why black holes are more than a topic about space. They are a test of whether the universe is a memory or an abyss. The answer lies where no one can look. A black hole is not a vacuum cleaner, not a monster. It is a boundary in space and time beyond which nothing can be proven outward again. And if you jump, the unsettling part doesn't happen to your body first. The unsettling part is the moment you still exist, but are unreachable forever. Black holes don't just show us how things vanish. They show us whether the universe can forget at all. If you had one last sentence, what would you send?
Cosmic Fates isn't over yet. The next episode is waiting below on the left.